Welcome to Physics and Chemistry Made Easy. Today we'll discuss about topic called as reflection of light at curved surface. 10th class Telangana State first lesson physics. Now what about this topic in class 9th? We have seen this topic in class 9th as reflection of light at plane surface. So this is a plane surface. When light incident ray falls on a plane surface, it gets reflected. It bounces back. Reflection means light bouncing back. So if you are drawing a normal at this intersecting point, normal which cuts at an angle of 90. So if you draw a normal, then what happens? The angle between the incident ray and this normal we call it as angle of incidence. And the angle between reflected ray and the normal we call it as angle of reflection. And very clearly we know that angle of incident is equal to angle of reflection. So these things we have seen in case of reflection of light at plane surface. Now today our topic is what? Reflection of light at curved surface. The topic is same, reflection, but it is in curved surface. Now what do you mean by curved surface? So you are taking a sphere, you are cutting it into two halves. This is one half and this is one half. Imagine a football, a volleyball, a basketball, or tennis ball. You are cutting it into two halves. Now what shall we do? Let us take that spheres and convert them into concave and convex mirrors. If you are coloring inside, if you are giving a coating inside, generally mirrors, when you speak about mirrors, they are coated with silver. Nowadays since silver is very costly, the inside coating is actually done by aluminium. And above it you will find again red oxide coating. Now actually, do you know one thing, very interesting thing? If you are standing in front of a mirror, right, your image appears much more brighter than what you are actually. The reason is very simple, that all the light that is coming from sideways, it is falling on that mirror and getting reflected on you. So automatically your image appears to be much more brighter. So same way now we are giving silver coating. Now for this let us color outside, we have given outside coating. So the reflecting surface means the surface where image falls. This is inside, reflecting surface is inside, reflecting surface inside. Therefore this is called as concave mirror. For this what we did, we colored inside, so the reflecting surface is outside now, outside, okay. Reflecting surface means the surface where image is formed. So reflecting surface is outside, therefore we call it as convex mirror. Okay, done, good. Then what else? Let us know basics and then we'll get into the lesson. Now the other one is what? Now I took a concave mirror. Just now I told you, concave mirror we are coloring outside. So there is a horizontal line drawn through the center of this concave mirror. So what happens? It is actually a sphere, isn't it? It's actually a sphere. It's a sphere like this. It's a sphere. So half of it, center, we take it as point of curvature. Let us divide this total distance into two equal halves. So that point, let us take it as focal point. Focal point. In the same manner, on the other side also you will find the same thing. Suppose you are coloring inside, you are coloring this one inside. Now as I said, this will behave as a concave mirror. This will behave as a convex mirror. Good. Then what happened? Whether it is concave or convex, it is out of one sphere. This is center of the circle, sphere, nothing but center of sphere. Then this part is also divided into two halves, therefore this is considered as focal point for convex. This is considered as focal point for concave. In this way actually curved surfaces are developed. Now we'll see will take consider into concave mirror. So when you take this concave mirror, as I said, this is called pole. This point is called pole. This is an horizontal line joining pole as well as curvature. Each spherical mirror has got its own working style. The working style of a concave mirror is light that is coming from long distance, okay? When it falls over the concave mirror, the working style of a concave mirror is to converge the light. Now where does it converge the light? It converges the light at focal point. All the rays converge at focal point. All the rays. I have drawn just 2 on the top and 2 below. It's not like that. All the light that is coming and falling on the concave mirror, what happens? Gets converged at the focal point. This is the working style of a concave mirror. Now we'll see what is the working style of a convex mirror. What does a convex mirror do? It diverges the light. So let's draw the same thing. So sphere, the other half of the sphere. Let us cover it inside. Let's color it inside. So as I told you, a reflecting surface is outside, but you will not find focal length, focal point and curvature on the other side because it is a sphere, isn't it? It's a sphere this side. Therefore, same thing, you will find curvature, point of curvature, and half of this distance from pole to curvature we take it as focal point. The working style of this convex mirror, is diverging the light. It diverges the light. Now where from it diverges the light? It diverges the light from the focal point. That means how? It's like this. Now I am drawing 2 lines coming, light coming from far distance, infinity. They fall on this convex mirror, and they get diverged. See, we find some of the students drawing like this. This will be considered as wrong. Take care. These are very important things. See, as you said, they are coming out of concave, isn't it? So you have to put a scale from joining this point and this point. So you have to draw the same line straight away, and this one darker. So from here you have to draw dotted and dark. So what is important? You are joining these points with F. That is very important. So put a scale. Just draw this dark line and go and dotted towards the F. So it's like this, darker and then F. It should be like this only. Then it is so clear. See, so clear. Simply you cannot draw somewhere from somewhere. It is exactly going away from the, diverging away from the focal point. Key points, simple points to remember. So what is that playing great role in these curved surfaces? It is focal point. Light falling on a concave mirror, it is converging. Now I will show you concave mirror. Just imagine if you are hitting a ball here, it cannot go on the other side. It will just, as you hit the ball here, automatically it will come down. If you are hitting the ball here, because this is a curved surface and this part is going up, so when you hit here, automatically it will go up. So automatically they are getting converged at up. So when you take your palm, as I said, I'll make signs easier. As I said, see, take palm. This side it is colored, this side it is little bit fair. This is common for everybody. So if you can do it like this, so this becomes your reflecting surface inside. So concave, because the other side you see, it is a bit different in color, not fair. So concave. If you can bend it like this, no, to your maximum, then it becomes a convex, but reflecting surface remains to be the brighter one, right? So it's like this. If you hit a ball here, it will go up. If you hit a ball down, it will go down. But if you do like this and hit a ball, if you hit a ball here, automatically it converges down. If you hit it here, it will go up and it gets converged at the focal point. So this way it is understood. Still, if you are having any doubt in your exam, just remember what I explained about the palm. You just take the palm like this. So this side you can see different type of color, this side brightness. So if you can do it like this, it's a concave, and he is saying converge light. and it will be converged at this point clearly. If you say like this, it is vex, I don't want to converge the light, so it's convex. Very nice, good. Now coming to the point, image formations. So before going to the image formation, we should know the exact rules to draw a ray diagram. So when you speak about a concave mirror and a convex mirror, we will see the difference. There are just 3 rules to draw ray diagrams. Rule 1, in case of a concave mirror, just now I said concave mirror is a converging mirror. Okay, so light which is coming from far distance, it will hit the mirror and it passes through the focal point. This is your first rule. Rule 2, when you speak about, as I said, it is a concave mirror. This is focal point and this is point of curvature. The second point is what? Light which is passing through the focal point. Light which is passing through the focal point, it goes parallel. Now what difference is there? Simple to understand. Light which is coming parallel to the principal axis, okay, this one, when it is hitting the concave mirror, it is passing through the focal. It has to pass through the focal point because the characteristic of this mirror is to converge. Just now I said no like this. Yes. Now what is happening here? This is similar to this one. There is no difference. Why you feel difficulty also, I don't know. So easy it is. This is similar to this one. This is similar to this one. What differs? Arrows. Just imagine if I can change these arrows. If I change these arrows, whether you take it from down, whether you take it from this side down or top, it doesn't make any difference. So it's same. See, same. Light which is passing through the focal point is going parallel. That means light which is passing through the focal point is going parallel. So if you can reverse the arrows, that is your second rule. Still I can say you can even draw the same diagram here. If you want, you can draw the same diagram. So the first one, as I said, once again I will tell you, this is what the first one is. Light which is coming from infinity, falling on the concave mirror, passing through the focal point. Let me draw the same diagram, tell you the second rule. What is happening? Nothing will happen, but I have to change the position of the arrow. The light which is passing through the focal point is going parallel. Parallel going through focal point, so through focal point is going parallel. Now coming to the rule 3. Rule 3. If a light ray happens to pass through point of curvature, suppose it is passing through point of curvature and falling on the concave mirror, it bounces back along the same direction. It bounces back along the same direction. Okay, that's all. Now coming to convex, we'll see rule 1 in convex. As I said, convex or concave, it doesn't make any difference. As I said, it is same. So the focal points will find inside focal point curvature. Why? I told you no, it is sphere. It's sphere. Whichever side you find sphere part only. It all depends upon the way you are coloring. If you are coloring inside and making the reflecting surface to come out, convex. If you are coloring outside and making the reflecting surface to inside, it becomes concave. Now the first rule is what? Here in concave, parallel. After touching the mirror, it is passing through focal point. This is same. Parallel, passing through focal point. This is called passing through focal point only. Why am I drawing outside? I am drawing outside because these are diverging mirrors. Yes, they are diverging ones. So they diverge outside. All this happens outside. The rule 2. This is rule 2. And this is a convex mirror. As I said, reflecting surface is outside. So parallel light after falling on a convex mirror, it got diverged from focal point. Now let us take a light towards focal point. After touching the mirror, it was parallel. Now you tell me, just now I told you here, there is no difference between these 2 points. Only arrow shows the direction of light. Here it is parallel, hitting the mirror, it is going through focal point. Now if a light happens to go towards the focal point after touching the mirror, it passes parallel. And the third rule also remains to be same to same. Right. Therefore, the focal point and this is curvature. As I told you, it's a sphere this side. So you will find all this inside. Right. So a light is passing. passing towards C. So what happens when it touches the mirror? It bounces along the same direction. This is your rule 3. Rule 3. Today is my first class. One of my friends suggested me to conduct this type of classes for the slow learners and also for the students who are above average. So this is the first class for me. Please kindly support me. Thank you. Yeah, this part is over. Then what comes next is very interesting topic. When you speak about a concave mirror and a convex mirror, convex mirror, concave mirror. See, convex mirror has only one characteristic image, only one. It forms only one image actually. Wherever the object is, it forms only one image. Therefore, the characteristic of image also will be only one, and that will be virtual, erect and diminished. Now, when you speak about a concave mirror, it forms 6 images. So, this forms only one image. Only one image. If you take concave mirror, it forms 6 images. 6 images. Therefore, what happens? 6 characteristics are there. 6 characteristics. Six characteristics. Now there are students who get confused with these two, whether convex is having 6, concave is having 6, all that. It is easy to remember. Remember this, no? Cave. Right? We get frightened, we get threatened to go into cave because so many other things can be there along with the lion, tiger, so many other things. So many. So you can remember one is 6 number and the other one is 1. So this 6 is matched to concave. So many, cave, so many other animals can be there. Like that you can remember. Tips. Now coming to this one convex, the opposite one. Okay, that's the opposite one because there are only 2 options, 6 and 1. Very good. This is one. The next one is, when you speak about a concave mirror, since the reflecting surface is inside, yes, concave mirror. Okay, so in front of the reflecting surface you find focal point. Therefore, always F is considered as negative. Remember, if it is lens or mirror, it doesn't make any difference. Concave, focal length is always negative. Always it is negative. Now, just for an idea I am telling you, cave. Don't you fear to go into cave? So you can remember fear factor negative. Fear factor negative. You will get frightened, threatened to go into a cave. So you are speaking about cave. So you can remember like that. It is for your remembrance. But I am giving you the actual meaning why it is negative. Because your focal point of this mirror is just in front of the reflecting surface. So it's quite opposite for convex. It's quite opposite for convex. Convex focal length is always positive. Why? Because this is the reflecting surface and focal length is on the other side of the reflecting surface. If the focal length is on other side of the reflecting surface, this is a surface which reflects, forms images. Okay? So if the focal point is on the other side of the reflecting surface, then F should be considered as positive. If the focal point is in front of the reflecting surface, then focal point should be considered as negative. Thank you. The next one is, so these many things are told. Okay, done, it is done. Now we will see image formations. See, this is a concave mirror. Just now I said concave, so many things. So you remember 6 images. So this is a axial line, this is focal point, and this is point of curvature. Okay? So the first position will be infinity, object positions. These are all object positions. What we are discussing right now is object positions. object is at infinity. 1 here, object is at infinity. Then comes what, from there it is here, object beyond C. This is called beyond C. Yeah, this point is called beyond C. Then comes what now? C. So on C. Then between C and F. Then it is on F. Then comes between P and F. That's all. Just 6 positions. Such an easy thing actually. Object is at infinity. From there directly it comes very close to C. Therefore we say it is just beyond C. Then comes on C. Now 2 points are here, F and C. Therefore it takes only 1 point. Wherever it is between these two, it is considered as 1 between F and C. This is on F. This is P. Therefore between P and F. 6 positions. Position 1 infinity. Position 2 beyond C. This is your C point, point of curvature. This is your focal point. This length we call it as focal length. This length we call it as focal length. This is called as focal length. This is called focal point. This is called point of curvature. So what is happening? Object at infinity, first position, then very close to C, so we call it as beyond C, then it is on C, then between C and F, then on F, between F and P. Position 1, position 2, position 3, 4, 5, 6. 6 positions. Right? Very good. Now we will see what type of images you get for each and every position with their characteristic. Now before explaining that, as I promised you, I'll make physics and chemistry easy. I'll give you an idea. See, this is your concave mirror. Principal axis. This is P, as I told you, pole. Then as I told you, it's a sphere, isn't it? It's a sphere. It's like this sphere. Therefore this is point of curvature. Then half of this we call it as, in between the point we call it as focal point. Shall I give you a neat clear idea for the 6 positions and 6 image positions? Very simple it is. If the object is on C, you will get image on C. That's all. That is a clear cut idea. Finish. I think it's over. Exactly speaking, it's over actually. It's over. If the object is on C, you will get image on C. Pakka. That much only. It's over actually. Now what next? Suppose object is moving this side. So it's here. Then your image moves on the opposite side. That's all. Now what else I have to explain you? So simple. If the object is on C, you will get image on C. So object has moved this side, image will go on the other side. If the object is moving this side now, image moves on the other side. So these two are moving reciprocal to each other. What confusion is there? One thing I'll tell you, simple. If the object is on C, you will get image on C. But that's all. If the object is moving towards left, image will move towards right. If the object is moving towards right, image will move towards left. Image, if it is moving towards left, it will be smaller than the object size. When the object is on C, just now I said, no, isn't it? Image will be on C. The size of the object and the size of the image will be same. Size of the object and size of this image will be same. Okay, at this point only these two are same. And the other thing I told you, if the object moves towards right, image moves towards left. So what is this position called? Beyond C. Object beyond C. If the object is beyond C, you will get image between C and F. If the object is moving this side, now the object, let us take this object. This is understood now. On C, it is same size. Now let us see, object has moved this side towards left. Therefore, image will move on the other side, and the image which moves on the other side of C, this we know position, we call it as beyond C. Same, it is beyond C for image. If you draw on the top, it is beyond C for object. So for this object position, this is your image position, right? And this is found to be very big one. Yeah, you'll get an enlarged image. We'll see all that enlarged image, right? Finish, over, done. Now it's over. So simple, it's over actually. Now we'll see what actually it is. Like this, it is concave mirror. So this is focal point, this is curvature. I need not draw from infinity and all that, no. I can simply remember one point saying that if the object is on C, I'll get image on C. And size of the object is equal to size of the image. Okay. When two sizes are, size is same size, a representation is given for same size, and that is 1. Representation is given. Magnification, we call it magnification. I will go to that topic. When I reach that topic, I will explain you. So it's same size. When the object is on C only, you will get image on C, and the characteristic will be same size. So if the object is here, beyond C, for that you will get the image here, between C and F. And just now I said, image which is forming towards left will be smaller one, right? This is done. If the object is here, that is what, between F and C, then you will get an image beyond C, that is very big one. Now look at the picture, same size, I said it is 1, then this is not same size, it is diminished. Therefore for diminished, the value is less than 1, so it is 0 point. It can be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8 and 0.9. Till then 1, it cannot be 1 because this is 1 already occupied. Now look at this picture, this is more than same size, so this should be considered as enlarged. So you have to give a value which is more than 1. It can start from 1.1, 1.1, 1.2, 1.3 and goes on. It's understood now. Okay, I hope you understood. Still, let me tell you, if the object is on C, you will get image on C, man. If the object is going right side, you will get image left side. If the object is coming towards between C and F, this side, then you will get image on the other side. This watch only. Now tell me, is it inverted or this is called inverted? So you mean inverted. The image is inverted. Image of a person is inverted. Inverted images are called as real images. Inverted images are called real images. Okay, so this is inverted. Okay, it's understood. So inverted images are also called what I said? Real. So this is inverted, so this is real. This is inverted. Sorry, this is real. All these images are inverted. So all these images are inverted. Inverted images are called real images. Done. Now this is of same size, just now as I said. This is diminished and this is enlarged. Such a easy thing. See, if the object is on C, you will get image on C. So the characteristic of that image will be real, inverted, same size. If the object is beyond C, you will get image here. Just move opposite, they move opposite. Still I want to make it easy, as my channel is making easy. The concept is so simple that if the object is on C, you will get image on C. If the object is moving on right side, image will be left side. If the object is moving left side, then the image will be right side. So image which is going right side, that is beyond C, will be bigger one. This side means image will be smaller one. Now real inverted diminished, real inverted same size, real inverted enlarged. See, real inverted, please, these are the very important point. Still, real inverted. See, in this lesson, real inverted is also given a symbol, and the symbol for real inverted is negative. Negative is the symbol given to real inverted. Therefore, this is minus, and this is also minus. Now tell me, it is less than 1. So we call it as diminished. So it's minus means inverted. Yes, real is inverted. This is also minus, real inverted. Minus means real inverted. Real inverted. And what did I tell you? If the object is on C, you will get image on C, I said. And on C means same size, same size. But it is reverse one, reverse one. So inverted. Inverted real. To say that it is inverted real, we say minus. Inverted real means minus. Okay. 1 means same size. Less than 1 means diminished. More than 1 means it is enlarged. These are the things given in this lesson. Very interesting. That's all. This part is over. These are the characteristics. Now if the object is on F, it is infinity. If the object is here, okay, you will get image in the mirror. Shall I tell you an interesting thing? If you are standing in front of a concave mirror, if you are standing in front of a concave mirror, you will not find your image in the mirror. No. All these images are caught on the screen. Real images are caught on the screen. Now what to do with the mirror? If you are standing between these points, pole and F only, your image will be seen in the mirror. It's actually, let me draw the same thing. It's like this. Your head, suppose your head and hands and legs. So your image is like this in the mirror. You are here. You are here. Hello. You are here. Yes. It's like that. It's not plane mirror. It is not plane mirror. The magnification of your plane mirror is +1. Plus means what? Virtual erect. 1 means what? Same size. Yes. If you are standing in front of a plane mirror, your size and the image size will be same. Your distance from mirror to you and the distance from mirror to the image also will be same. What differs is the lateral inversion. If you lift the right hand, it appears as if you are lifting the left hand. That is in plane mirror. Don't come into this lesson with plane mirror. This is different one. Wherever you stand in front of a plane mirror, image will be caught. This is not like that. This is not like that. All these positions, infinity, beyond C, on C, between C and F, on F, between F, till here, your images are not seen in the mirror. No, you will not be seen in the mirror. So if you go to exhibition where mirror exhibition, the moment you enter inside, there will be a plane mirror. So you along with your father you went. So you will see your images in the mirror. Then you will turn right. There will be a mirror in front of you. Clearly a mirror is seen, but you will not appear in that mirror. What will you think? Wow, it's a wonderful thing. I am not seen in a mirror. This is the first time happening, daddy, like that you will say. But you know the interesting thing? That's a concave mirror. And you know your position, you are at infinity. So you will get a point size image on F. Infinity, parallel lines converge at focal point. Then after slowly you will be walking. You are very close to C. Beyond C we call. Still image, what happens? Image is not caught in the mirror. Then you will stand at a position called C. They will write down there, stand here, stand here. Right? Stand here means what they are trying to do. One will be beyond C point. Other one will be on C point. Other one will be between C and F point. Other one will be F point. All these cases, your image is not found in the mirror. Now when you stand between F and P, your image will fall in the mirror and that will be a huge one, big one. So you will really get surprised to see all this. But what is actual concept behind this? It is a concave mirror, a spherical mirror. It can form image in the mirror only when you are between F and P. Okay, done. Thank you. Now, right. So the characteristic, this is now erect. Erect. The opposite of invert. The opposite of invert is erect. Invert is like this. Erect is like this. So this is erect. Erect is always virtual. Erect is virtual. And this is the object size. This is image size, very big one. Therefore it is called enlarged again. Virtual, erect and enlarged. Now virtual erect, see I told you real inverted you are giving minus sign. So for virtual erect, virtual and erect, for virtual and erect we give the sign plus, plus. So what shall I do? Plus. Now you tell me, I gave plus. Plus is to indicate that it is virtual erect. Minus is to indicate what? Real inverted. Once again I am telling you, minus means it's real inverted. Minus means real inverted. listen to me, if you just simply write like this, it has got all the characteristic. Minus means it is real inverted, it is more than 1, so it is magnified or enlarged. Enlarged or magnified both means same. So interesting. If I write like this, then the three characteristics is, this is understood minus real and inverted, but 1 indicates that it is same size. So image is forming on C. If I write minus 2, real inverted, enlarged, that means it is beyond C. So like that it is understood, virtually red plus 1, and you can write some sign which is more than 1, more than 1. More than 1. Good. Now I want to draw the diagram. Before that I want to ask you a question. Now minus 1 and minus 2, which is bigger? Which is a bigger value? Many of you will say that minus 1, minus 2, so you are following the number line. So it's 0 over here, 1, 2, 3 and it goes on, positive. And this side is minus 1, minus 2, minus 3 and minus 4 goes on. So generally speaking, as you move this side, it is increasing, and as you move this side, it is decreasing numbers. Everybody knows. 0 is better than minus 1, because minus 1 is less than 0. Minus 2 is much more lesser than 0. It's understood. But the thing is, this is number line. But interesting thing here, as I was telling you about number line, when you speak about these two, which is greater? Minus 1 is greater than minus 2. But here the interesting thing is, minus 2 is greater than minus 1. Exactly. Minus 2 is greater than minus 1. See, nothing I erased. It's here. I am making it very clear. This point. This is regarding your number line. The values, as you know very well, minus 1 is greater than minus 2. Why did I say minus 2 is greater than minus 1? Because just now I said no. Minus means it is inverted. 2 means it's big one. What does minus 1 indicate? Minus indicates inverted only. Alright. 1 indicates that it is of same size. You know the meaning of these two? If you know, right, I will draw here. If you know the meaning of these two, so clear, see. Very important, interesting thing I told you. Now tell me which is greater. This one only. That's why I proved it. What does, these are not the values, these are magnifications. Your first lesson does not follow number line system, it follows magnification. It says that minus means inverted. Right? 2 means greater than 1, enlarged. Now see, what does this indicate? This is 1. So this is twice of this one. Twice. So see, minus indicate both are inverted. 1 means this is 2. 2 means it is twice greater. So proved minus 2 is greater than minus 1. Okay. Now we will draw diagrams.